So keeping inheritance in mind, let's take a look at the rules to follow or requirements. So the first rule is that the client must use an abstract interface to an abstract factory to manufacture instances of object supply. So just like we have a hierarchy of objects in the hierarchy, so this is what we need to be able to manufacture. Likewise, we will have a matching hierarchy of factory classes to manufacture instances of object supply, and we'll use abstract factory interface. Client must also use an abstract interface to access object supply. So this is something that we discussed in previous video. So let's construct a class diagram to illustrate abstract factory design pattern using a Violet UML editor. If you recall, we have a link to our schedule, and I think in number 3 we have links to Violet UML editor for you to download, and pretty soon I'll start using the sequence diagramming tool as well. So I'm just going to create a new class diagram. And for example, say that we have a multi-story building with various shops and outlets at different floors. So we would like to run a simulation of shoppers visiting the shopping center. So the shoppers and other types of visitors arrive at the garage floor or at the ground level lobby. So we need a supply of visitors. So I'm selecting a class type, clicking right here, and then specifying that the name of this class is going to be visitor shopper. Okay, so this is a type of visitor in my system. I call it visitor shopper, and this specific class represents a specific type of visitor. So we also may want to simulate emergency situations in the building for facility testing and personnel training. So let's add a visitor for emergencies. So this is basically emergency worker. So another class, and I will call it visitor emergency. So we have an emergency, we can have this type of visitor in the system. So the purpose, implementation, and responsibilities of these objects are different. However, they both are related and have common parts, okay, because they represent people entering the building. So therefore, we can form a hierarchy of these classes with a common base. So I'm thinking we can create another class named visitor. And we can now form this hierarchy of classes so that we can, of course, use inheritance relationship and specify that both of these classes inherit from the visitor, the common base. Let's also add class name simulation scenario. All right, something like simulation scenario right here. And this new class will keep track of all visitors, and based on the current situation, like normal operation or an emergency such as building fire, it should create the visitors which are shoppers or emergency personnel. So that's why we can perhaps use a factory class. So I'll just add to the attributes something called factory. Okay, so we'll have factory in the system, and it will probably use some sort of factory interface, and this will be an object to construct visitors. So I'll call it iFactory visitor. You already know that in UML, when you specify data attributes, its data type can be specified next to it using the colon sign, and this is the data type. So I prefer to name my interfaces with a capital I in front of the interface name. So of course I need this interface somewhere in the system. So I'll just use an interface right here, and I will use the interface object in the diagramming tool section. And of course this interface will be named in factory visitor. So basically the simulation scenario, which is an application class, business object that wants to create these visitors, will use this interface. So of course we can just specify an association right here because this is pretty much the reference to this interface. A set of available operations in the simulation scenario will be a constructor. So again, I'm switching to the properties of my simulation scenario, and the first method that I would like to specify will be a constructor. So it's a public method, that's why I use the plus sign, and I prefer to illustrate constructors in the diagrams and class diagrams specifically using the new word. And here we'll use this factory visitor as a parameter. So from the point when the simulation scenario is created by its constructor method, constructor operation, the constructor will get this factory as a parameter. Now I also want to have a method named setFactory so that I can switch to different factories, because I may need various types of visitors in the system. I may need to have different factory types of objects to manufacture the corresponding visitors. So what I will also want to add here is the method named setFactory. Okay, and again, just like constructor, it takes factory as a parameter right here, and it will use this method, or we can use this method to specify the factory object that we would like to use. And once this setup is ready, so either by using the constructor or using the setFactory method, we can now create visitors. So this will be an operation available here that I'd like to call create visitors. And you see that the parameter here simply will be a visitor count. So how many visitors would you like to create? So the simulation scenario allows me to generate visitors, and of course what is part of the simulation scenario is that we're going to have a set of visitors in our attributes. So here will be another private attribute. I'll call it visitors. So this will be collection of references to our visitors, and the visitors will be some sort of a list. Okay, so this will be a list of visitors. So the list of visitors will be parameterized by the visitor type of object. Okay, so this will be my list of visitors inside here. And then once the configuration is complete and some visitors are created, now I can use typical scenario execution methods that would allow me to basically start the scenario, or I can say play. Okay, so play will start running the scenario, and then I can have a pause in my simulation scenario, and also can have a stop. Okay, so these are methods just to demonstrate some kind of functionality here. So since we have this scenario class, and I will select multiple objects here and move them here, and of course the simulation scenario has this reference to the visitor, right? So the list of visitors here we can have inside the scenario, and of course perhaps we can specify the multiplicity here, so that the label here will be at the end point an asterisk. So we can specify that many visitors can be created by the simulation scenario by calling the method createVisitors. And so this is our association. So UML uses the association in the diagram, but internally we know that there is a collection of visitors, so some sort of list parameterized by this type of the data.